Rapamycin is a compound you might not have heard of yet, but one that's stirring up significant excitement within the scientific community. Discovered in the soils of Easter Island, rapamycin has traversed a unique path from its origins to becoming the single most promising compound currently in anti-aging research. Imagine a world where aging is not synonymous with decline, but is a process we can approach with control and grace. Stay tuned and prepare to be intrigued by the future of aging. Are you curious about how rapamycin potentially slows the aging process? Then commit to your well-being by tapping the like button and subscribing to our channel so you don't miss a thing. We are your portal to the secrets of longevity. The discovery of rapamycin in the remote soils of Easter Island, or Rapa Nui, marked a significant turning point in anti-aging research. Initially isolated in 1972 for its antifungal properties, the future of rapamycin was unexpectedly linked to human longevity. This pivot from a straightforward antifungal to a prospective anti-aging marvel exemplifies the unpredictability inherent in pharmaceutical developments. The key to rapamycin's potential lies in its ability to modulate mTOR pathways, explained shortly, which play a crucial role in cellular growth and longevity. This insight opens up new avenues for understanding the aging process. Rapamycin's transition from a soil sample on Easter Island to the leading edge of anti-aging science illustrates the surprising and vast potential in the quest to comprehend and influence how we age. As mentioned, rapamycin operates through a fascinating mechanism, primarily impacting something in our bodies called the mammalian target of the rapamycin mTOR pathway. This pathway is central to our cells' growth and aging processes. mTOR acts as a master regulator, integrating signals from nutrients, growth factors, and cellular energy states to influence cell growth, division, and longevity. Intriguingly, rapamycin effectively puts a brake on the cellular aging process by inhibiting the mTOR pathway, thus promoting longevity. This suppression of mTOR activity is believed to mimic the effects of caloric restriction, a known method for extending lifespan in various organisms and possibly in humans as well. Rapamycin's unique role in modulating this pathway allows it not only to slow down the aging process, but also to offer potential benefits in enhancing the body's ability to repair itself, thereby fostering rejuvenation and delaying the onset of age-related diseases. The impact of rapamycin on cellular growth and longevity suggests a promising frontier in anti-aging research. For instance, research on mice has shown that when rapamycin was administered, there was a significant increase in their lifespan, suggesting that the drug could delay the aging process. Similar studies in other organisms like yeast, fruit flies, and worms have consistently demonstrated lifespan extension, indicating a universal mechanism at play. These findings are remarkable for their demonstration of longevity and their potential implications for human health. The mechanism by which rapamycin extends lifespan in animals can theoretically be applied to humans. Hence, we might be on the cusp of a revolutionary shift approaching aging and age-related diseases. Rapamycin's ability to rejuvenate and regenerate at the cellular level is directly due to its ability to stimulate autophagy, the body's natural cellular cleanup process. Autophagy, derived from the Greek words for self-eating, is a vital mechanism by which cells break down and recycle their components. This process removes damaged proteins and organelles, maintaining cellular integrity and function. Because rapamycin inhibits the mTOR pathway, it activates autophagy. Autophagy helps to clear out cellular debris, including misfolded proteins and damaged mitochondria, often implicated in aging. By enhancing the body's ability to clean and repair itself, rapamycin not only slows down the biological markers of aging, but could also theoretically reverse some aging aspects, offering a potential pathway to a more extended and healthier life. This connection between autophagy and rapamycin's anti-aging influence is arguably the compound's most promising avenue for extending longevity. Keep watching to see how rapamycin combats age-related diseases. Studies suggest that rapamycin's mechanism of action could not only delay the progression of neurodegenerative diseases but also mitigate the risk factors associated with certain cancers. For Alzheimer's and Parkinson's, the drug's enhancement of autophagy is particularly relevant. This process could help clear amyloid beta plaques and alpha-synuclein aggregates, which are hallmarks of Alzheimer's and Parkinson's respectively, potentially slowing disease progression and alleviating symptoms. In the context of cancer, rapamycin's ability to inhibit cell growth and induce autophagic cleaning might reduce the proliferation of cancer cells, offering a novel approach to cancer therapy. Scientists are tirelessly working to translate the promising outcomes observed in laboratory settings into tangible benefits for humans. A notable example of this is the National Institutes of Health's Interventions Testing Program, ITP. The organization has been at the forefront of identifying substances that potentially extend lifespan. Within this rigorous testing framework, rapamycin has emerged as a standout, surpassing all other tested substances by a notable margin in its ability to enhance longevity. Among the most compelling areas of investigation is the effect of rapamycin on the immune system. Several studies suggest that low doses of rapamycin may actually bolster the immune response in older adults, potentially offering protection against diseases that become more common with age. Testimonials from participants in these trials speak volumes. For instance, John, 72, who participated in a rapamycin trial, noted, "I haven't felt this good in years. It's like my body has found a new lease on life." John's testimony isn't unusual for many participants in rapamycin clinical trials. For example, the article "Blazing a Trail for the Clinical Use of Rapamycin as a Geroprotector" in Geroscience, 2023, 50% of rapamycin users agreed that rapamycin improved their health, while about 25–38% of rapamycin users felt younger, more confident, more energetic, and/or helped with other perceived health benefits. While rapamycin's potential benefits in extending human health span are profound, it's essential to consider the drug's possible side effects and risks. Research has indicated that, although beneficial in many aspects, rapamycin can have adverse effects, mainly when used over a long period or at high doses. Common side effects include mouth sores, increased susceptibility to infections due to immune suppression, and elevated cholesterol levels. Additionally, there's the potential for more severe implications, such as lung or kidney toxicity in some individuals. Given these considerations, ongoing and future studies must closely monitor participants for adverse reactions and develop protocols that minimize risks. Balancing the drug's promising benefits against its potential negatives is crucial in ensuring it can be safely harnessed for human longevity purposes. Initially approved by the FDA for its immunosuppressive properties in preventing organ transplant rejection, the potential repurposing of rapamycin as an anti-aging therapy brings numerous regulatory obstacles to the forefront. Currently, rapamycin has yet to receive FDA approval for anti-aging, which necessitates comprehensive research to establish its benefits and risks in the context of aging. Ethically, the use of rapamycin for anti-aging sparks debates over accessibility, long-term consequences, and societal implications of extending the human lifespan. Questions arise about whether such treatments would be available to all or only a privileged few, potentially exacerbating existing socioeconomic disparities. Furthermore, the long-term effects of rapamycin remain uncertain when used for extended life extension periods. Before rapamycin can be widely endorsed for anti-aging, extensive, rigorous clinical trials need to be conducted that conclusively demonstrate its safety. Effectiveness and benefits outweigh potential risks in aging populations. Despite the potential risks, many are willing to take a chance on rapamycin for its promised longevity benefits. People seeking rapamycin for anti-aging purposes obtain it in a few ways. Some find physicians willing to prescribe it off-label, while others turn to telemedicine platforms specializing in longevity and anti-aging. The demographics of individuals consuming rapamycin for anti-aging purposes are as diverse as their motivations. They often include middle-aged and older adults from various professional backgrounds who share a common interest in extending their healthy lifespan and minimizing the effects of aging. This group consists of tech entrepreneurs and biohackers from Silicon Valley, healthcare professionals, scientists, and everyday individuals intrigued by the potential health benefits. Despite the varied backgrounds, these users are united by a proactive approach to health and longevity, often well-informed about the latest research in the field. Dr. Alan Green may be one of the most familiar faces regarding rapamycin for anti-aging. Dr. Green, who practices in Little Neck, New York, is reported to have treated nearly 1,500 patients with rapamycin since 2017. He has referred to rapamycin as the most important drug in the history of medicine and has prescribed it to about 250 patients. Are you considering supplementing with rapamycin, or have you already embarked on this journey? In the comments below, we'd love to hear your experiences, thoughts, and outcomes. I hope you got a ton of value from this video. Thank you for watching.